So let's look at chapter 18, which is graphs. 18.1, we are supposed to learn how to find the gradient of a graph. So calculate the gradient of the graph. You can either use the triangle method, which is easier, provided that your scales are correct. You just need to see a change in y over change in x. So just pick 2 points if you want to. You can use the triangle method. Pick these 2 points, you can see how much higher did it go? How much higher? One unit. How much wider did it go? 1, 2, 3, 4 units. So up 1, down right 4. So this is your gradient if you want to do it using your triangle method. This is for line B. But if you want to use coordinates, which is better and more accurate most of the time, because sometimes the scales are different. So this is a little bit what I call foolproof. So -3, 3, and then we find the other one here, which is 1, 4. And let's try to find A as well. So we get this one is 1, -2. Here, which is 3, 4. So let's find the gradient for A. Gradient for A, which will be this line here. You can see. So if you want to put change in x, change in y, a change in y over change in x is fine. Means you can see 1, 2 right, 1, 2, 3, 4, 5, 6 up. So 6 over 2. 3. You can do this if you want to. So it's basically change in y coordinate over change in x coordinate. Then you can get this one here. So up being positive, down being negative. You have to go to your right for your x. Okay, but if you don't want to use it, you want to use the other method, which is calculating method. Then use m is equals to y2 minus y1 over x2 minus x1. Gradient would be y2 minus y1. I always take the one on the right as my y2. It's just more of a habit. And then it's easier for me because that is confirmed. So 4 plus 2 over 2, 6 over 2, 3. All right. You should be able to do it like that for calculating method. Most of the time, the calculating one will work flawlessly, unless you name the wrong coordinates, then yeah, then there'll be a problem. So let's use the triangle method for B as well. And change in x is at the bottom to 1, 2, 3, 4. So you can write change in y over change in x. Change in x is 4, change in y is 1. Going up now, you can see, going upwards is 1. So answer is 1 over 4. Done. If you want to calculate, m is equal to y2 minus y1 over x2 minus x1. 4 minus 3, 1 minus -3. 1 over 1 plus 3, 1 over 4. That's it. So you might feel like the triangle method is a lot faster, a lot easier. Yes, well, it is. Most definitely is. It's just that you need to make sure that the scales are right. Okay, so let's look at number 2. Work out the gradients A, B, and C. So look at A. They didn't give you the coordinates, so it's up to you. Wherever you want to put it, it's up to you. Whichever coordinates you want, it's fine. If you want to use a triangle, also fine. Doesn't really matter. Look, I want to use here and here. So you see, 1 to the right, 1 up. You must go right first. So m is equals to change in y over change in x. Change in y is 1, change in x is 1, 1. If you want to use a coordinate, then sure, why not? Let's name the coordinates 1, 3, 0, 2. So m is equals to y2 minus y1 over x2 minus x1. If I have to write the formula every time, it gives you no excuse to not write it. 3 minus 2 over 1 minus 0. Same. Done. Let's look at B. This line. So pick 2 coordinates. Okay, if you have a question whether you can pick here or not, yes, you can, but you have to be very accurate. Means that you have to make your decimals correct. Okay, but let's not push our luck. Let's just take those that are sure shots. So this one is 3, 2. This one is 2, -2. So you should be able to find m is equal to 2 minus -2, 3 minus 2, 2 plus 2, 3 minus 2, 4 over 1, 4. Done. If you want to use the triangle method, sure, why not? Let's try again. M is equals to change in y over change in x. 1. 1, 2, 3, 4. Okay, if you're confident to use the triangle method, then you can do everything very, very fast. Next, question C. Click here, click here. Triangle method, change in y, change in x. 1, 2, 3, 1. Done. Calculating method. M is equals to y2 minus y1 over x2 minus x1. -1 minus -2, 1 minus -2. -1, -2, -2, 1 plus 2, 1. Same answer. So 1 and 2 done. Number 3, let's do this. Work out the gradient A, B, and C. They actually draw a triangle for you, but this is going downwards, so you actually get a negative gradient for this. So since you can get a negative gradient, so you must be prepared. 1, 2, 3, 1, 2, 3. Look at B is like that. This is 1. No, we don't call it 1 here. I think this is 1. 1, 1, 2, 3, 4, 5. I think this is a bit of a typo here. I think it should be like that. This is the point, this is the point. Okay, so let me just erase that for them. Right, okay, let's look at number 1, A. Gradients are negative, so these are given to you as a tip. So if you want to use m is equals to change in y over change in x. Change in x is 1, going to the right. Now we're going downwards, 1, 2, 3, 4, 5. Should be -5. As you can see, before I get my answer, it's given to me that the gradients are negative because they're all going downwards. If your answer is not negative, you are wrong. So let's put coordinates 3, 2, -3, -2. So m is equals to y2 minus y1 over x2 minus x1 is equals to -3 minus 2, 3, oh, it's 4. Four minus 3. That's the answer. Okay. All right. And that's the B. Let's get 2 coordinates for B. 2, -1, -1, 2. Change in x, change in y also can. Change in y, change in x first. 1, 2, 3, 3. Change in y is going downwards. 1, 2, 3. Calculation method. You just have to pick whichever that is easier for you. Okay. Whichever method that's easier, just pick that one and then you should be able to do it. So B done, let's look at C. C. Move it. 1, 2, 3, 4, 1, 2. So you can see gradient is supposed to be -2/4. Negative 5. This is when you use change in x over change in y. Okay, so if you use the calculation method, well, just label your coordinates. Sorry. Look at it, they are the same, by the way. Just pay close attention. Not one better than another, well, one is faster than another, but provided that the skills are correct and you are very accurate. Okay. Work out the gradients of P, Q, and R. P, Q, and R. So now let's just label them with colors so it's easier for us to see. So let's label P first. Now, if I pick two coordinates here, I would pick here this one and this one. I would use the triangle method. You can see 1, 2, 3, 4. For x, 2, 5. This for P. So let's just write properly. Gradient for P. Now, gradient for Q. Change the color. Q. No, Q. We're going to pick the same coordinates here as well. 1, 2. 1, 2, 3, 4. Sorry, my bad. The first one is negative. In a positive side, going upwards. My bad. Up, not down. This is going down. Okay, the next one is going down as well. So this is a negative graph. So just bear in mind, negative. Change in y over change in x. Change in x. 1, 2, 3, 4, 5, 6. 1, 2. Right. Set. Look at number 5. If you're using the calculation method, you can just use it to check. Okay, so now this is where your triangle method gets a little bit difficult. Show that the gradient of line D is 2.5. So line D. So what you would do is that, oh, then you say, oh, we can use the triangle method. Sure. 1, 2, 3, 4. 4. 1, 2. 2/4. Answer is 1/2, 0.5, which is wrong because we want it to be 2.5. Now you might figure, what is the problem here? Well, the problem is lies on the scale, not on the x-axis, but on the y-axis. Look at the y-axis. Each block represents 5. So the changes is not 1, 2, 3, 4, 1, 2. It's actually 1, 2, 3, 4, 5, 10. The answer should be 10/4. So this is the weakness of your triangle method. When you get too complacent, you might think that it is just 1, 2, but you didn't look at your scales here. So they did ask you as a tip to tell you to look at the axis. If you use the triangle method, you get it correctly, very good. But if not, you have to rely on your calculation method. So A for gradient for D is equals to y2 minus y1 over x2 minus x1, 15 minus 5 over 2 minus negative 2, 10 over 4, 2.5. Same. Right? So now, since you know the trick, you can actually use your triangle method for the rest. But when you count, please count it out loud so that you can hear yourself. 1, 2, 3 is gradient for E. 5, 10, 15. This is the answer. Now, gradient for F. Change in one. Always remember to do the X one first. Huh? F, I just pick this one. 1, okay. -5, -10. Okay, F is going downwards, E is going upwards. Great. Work out the gradients A, B, and C. So yeah, pay close attention to the grid again. So you can use your triangle method. So I'm just going to use the triangle method here. For A, I'm just going to pick this point and this point here. So M is equals to change in Y over change in X. 1, 1, okay, 1 first, because the Y-axis is different. Also 1, it's like X-axis is different this time. 20, 10 to 20, so it should be 10. My bad. Now this is another trick. This is 10. Then 1, 2, 3, 4, 5. 5 over 10, gradient is half. Now B. 10, 20, 30, 40. 1, 2. B. 10, 20, 30, 40, 50. -1. Done. Second, number 7, yes, it draws straight line through points here and here, draw the line in the grid, find the gradient of the line. So without drawing on the grid, you can actually find the gradient first. So let's try to find the gradient using my calculation method. So Bm is equals to y2 minus y1 over x2 minus x1. Let's just use these two coordinates, then 5 minus 2, 2 minus -4. So if you want to prevent yourself from making mistakes, I would suggest you to pick the ones without negative so that's easier. Six minus 5, 4 minus 2, 1 over 2. Done. So you can draw it on the grid. I'll just draw it right here. I need to go up to 6, 1, 2, 3, 4, 5, 6, 1. -4. Two and 6. 6 is there. Right there. We don't need a negative for the y-axis. So let's just plot our graphs here. We should get -4, 2, 2, 5, 4, 6. Here's my graph. So we're going to use the change in x and change in y. 1, 2, x is change in x is 2, change in y is 1. So gradient is 1 over 2, same. Right? So you can use this and look at it as well. If you can imagine your coordinate grid, very good. If you cannot, then you must calculate. So question 8, question 9, you just calculate and find the gradient. So question 8, by now you should know your formula already. So m is equals to, you can recite it in your head so that you can do it. y2 minus y1 over x2 minus x1. Using these two coordinates, by the way. 2 plus 4 over 3, 6 over 3 is equals to 2. Coordinate for B, m is equals to, I will use these two coordinates, y2 minus y1, x2 minus x1. Same thing again, I will just put it in my head, I will just use these two to calculate that. M is equals to y2 minus y1, x2 minus x1. Question D, do it in your head again. I'll just pick these two because they are positive. y2 minus y1, x2 minus x1. Gradient is 0, so this must be a flat line. If you remember, this is your y is equals to 3 line. Now, number 9. 9a, calculate these two. So m is equals to y2 minus y1, x2 minus x1, 12 over 2, 6. Just use these two. So I will use these two. y2 minus y1 over x2 minus x1. B, m is equals to use this one and this one. y2 minus y1 over x2 minus x1. Last one, question D. I'll use these two because I don't like to touch the decimals. M is equals to y2 minus y1 over x2 minus x1. 1 minus 10, 1 over 0 plus 10, 10. And done.